Hello guys, Rajat again. So I'm back from my office because I'm doing night shifts. So I wanted to quickly talk about uh, most important data structure which you should master in order to master the remaining data structures like stacks, queues, heaps and all. And that data structure is one-dimensional array. The computer memory is arranged as a contiguous blocks of smaller memory chunks. So that is a natural representation of computer memory and it is sort of a one-dimensional array. So one-dimensional arrays in your programming languages are a natural representation of how the memory is structured under the hood, and all these abstract and higher level data structures utilize these one-dimensional arrays to implement their functionality. So one-dimensional arrays are as close to the metal as you can get. So you have to master the one-dimensional array. What do I mean by mastering one-dimensional array? So in most of the computer programs, you are going to iterate over a one-dimensional array. So you really have to have that intuition about how your program is going to react in case you try to access an uninitialized block of memory from that array. Is it going to fail? Is it going to throw an error? Or is it going to have some non-deterministic output? So you need to be very clear of that particular thing, and you can only develop this sort of intuition by carefully running that program in your mind and writing more and more different sort of programs using one-dimensional arrays. So when you are going to do that thing, you are going to develop an intuition and a natural tendency to clearly see the pattern of how your program is going to react. So that is something you need to master, because if you go to any coding interview, they are going to ask you that write or implement some sort of data structures or solve some abstract problem, and most of the times you are going to fall back to a one-dimensional array to write your programs, right? So in that case, you are required to dry run your program in your mind, and if your intuition is strong enough, if your dry running capability is strong enough, you will be able to figure out how your program is going to react if there is some edge case like the array is empty. You have to be really clear about that thing. The second thing you should really master about one-dimensional array is how many iterations you actually need. So like if you are given an array of n numbers, so you really need to be clear about, do you really need those n iterations, or can you make do with n minus 1 iterations? And in most of the algorithms like bubble sort and all, you can actually get away with using less than n iterations, and n minus 1 to be exact. So like you need to be very clear about that, can you save CPU cycles? And in some of the interviews, there can be a follow-up question to optimize your program further in case you have used those extra iterations, and the interviewer is able to figure that out. And you can avoid this sort of follow-up questions by just doing away with these non-required iterations from the get-go. So am I suggesting that you should really master your one-dimensional arrays before moving on to topics like sorting or algorithms like greedy algorithms, graph implementation, trees and all? I'm certainly not suggesting that. What I am suggesting here is, when you implement these higher level constructs or when you utilize one-dimensional arrays in your program, try to run your program in your head and try to see if your program fails under some edge scenarios, or if your program is using one or two or more extra iterations for no apparent reasons. Because when you can do that in your mind, you can present your solutions and deploy your solutions with more confidence. And this thing can really come handy during interviews, because in interviews you really want to be sure that your program is not going to fail under trivial cases or edge cases, and it is not wasting CPU cycles, it is not doing some extra work just to gain nothing. And this will also develop you as a proficient programmer as well. So that is everything I wanted to talk about. So be wary of how you are utilizing one-dimensional arrays in implementing higher level concepts like sorting or trees or graphs, etc. So if you have any more question about this topic, do not forget to leave a comment on this video. I'll try to address your queries to the best of my knowledge, as I always say. And if you're new to this channel, we talk about real world software development and theoretical computer science on this channel on a weekly basis. So do not forget to subscribe this channel, and if you like this video, give this video a thumbs up, and I'll see you around. Take care. Bye bye.